In this video we'll take a quick look at how to differentiate exponential functions, so e to the power of something. So our function might look something like y equals e to the x. Now the cool thing about this function is that it actually differentiates to itself. So dy dx is actually exactly the same function. And the reason for this is kind of cool. If you think of a, well, it's really not a straight line, hang on. We'll try again, there we go. If you think of a standard exponential function, they tend to look a bit like that, passing through 1. So if this was, for example, the function y equals, say, for example, 2 to the x, that would mean here at 1, for example, that would have a value, that would be 2 to the power of 1, so that would be 2. At 2 to the power of 2, it would have a value up here of 4, and so on. And the gradient we can calculate through calculus. However, the cool thing about e to the x is that when you sketch that graph, obviously these values are slightly different, I'll get rid of them. The value that you get, so for example, e to the power of 1 is e to the power of 2 is e squared, so whatever those values are, they're actually exactly the same as the gradient of the curve at that point. And that is what it means when over here we say that it differentiates to the same thing. So anyway, practically, what does this mean for you? Well, if you're differentiating an exponential function that has another function, for example 2x here, in the power, we just need to use the chain rule. And so to differentiate this, what we do is we say, well, it's exactly the same. E to the x goes to e to the x, so e to the 2x goes to e to the 2x. But because we have this pesky function up here, we then have to multiply by the derivative of it, so that is going to be 2. So this equals 2 lots of e to the 2x. Another example, if we have a function here, y equals e to the 3x squared plus 4. When we differentiate this, we know that e to the x differentiates to e to the x, like up here. So in our example down here, we know that this will remain exactly the same, e to the 3x squared plus 4, and then we multiply it by the derivative of this function up here, which is going to be 6x. So we end up with 6x times e to the 3x squared plus 4. The time to be, I guess, a little bit prepared for is if you have a function at the top there in the power that has multiple terms in it. So if we had, say, 2x squared plus 3x in the power, when we differentiate this now, e to the x differentiates to e to the x, so the e stays the same. And then we multiply this by the derivative of the power. Now that has 2 terms, so we need to pop this in brackets. So that will be 4x plus 3. And you can leave it just like that. So that is how you differentiate an exponential function where e is the base.